Solubility. With solubility, we have to talk about the intermolecular forces between solvent and solute. So it's not just between esters and ester. We have to look at like between esters and water molecules. Okay? So in general, like dissolves like. So those molecules that has some polar features are more likely to dissolve in water. Okay? So dissolving water is like stealing water molecule from its own kind. Okay. So water molecules are bonded together through hydrogen bond. So water can form hydrogen bond with itself. Okay. So to dissolve in water, the solute must be able to form stronger bonds with water so as to steal water from its own kind. So if the solute can form really, really strong bonds with water, for example, ionic compounds, right? Ionic compounds, when it goes into water, it will break into ions. Ions has real charges. And therefore, they can really steal water molecules from its own kind because real charges trumps the hydrogen bonding, which is the bonds between partial charges between hydrogen and oxygen, right? Okay. So if solute can form strong intermolecular forces with water, then the solute is more likely to dissolve or dissolve more. So with water, alkane or alkyne, and haloalkanes are insoluble because they can only form weak dispersion forces with water. Or maybe you would argue that haloalkanes can also form a little bit dipole-dipole with water, but they're not strong enough to break into water's hydrogen bond with itself. So with small aldehyde ketone ester, alcohol amine, amide, carboxylic acids, they are generally soluble because all of those aldehyde ketone ester, including aldehyde ketone ester, they're all forming hydrogen bond with water because although they don't really have the hydrogen bonded to the oxygen or the nitrogen in some cases, but water has a hydrogen bonded to the oxygen. Therefore, that hydrogen in water can form hydrogen bond with the oxygen in these molecules. Okay? Solubility in water decreases as chain length increases, when we compare between the same homologous series. So, for example, we saw this table before with for carboxylic acid. The small carboxylic acid can dissolve like almost unlimited amount of it. So as long as you have water, they will actually dissolve in water. But you'll see that as the carbon chain gets longer and longer, the solubility actually decreases pretty sharply. Yeah. Okay. The solubility in water is the opposite of the solubility in nonpolar organic solvents. So alkane, alkene, alkyne, and haloalkanes are all soluble in nonpolar organic solvents, for example, in acetones. Okay? So the solubility of aldehydes, ketones, esters, alcohols, amines, amides, those ones that can actually dissolve in water, they can also dissolve in nonpolar organic solvents, and their solubility actually increase as they get longer and longer and longer. Okay, so you'll be like, okay, so why is that? Because for all of them, they all have the they all have the organic part, which is the hydrocarbon chain. So they can still dissolve in organic solvents because like dissolves like, right? Although they have the polar part, right? But all of them will have nonpolar part. Therefore, some small alcohols are great solvent for both organic and inorganic substances because they all have a hydrophilic part, which is their functional group, and the hydrophobic part, which is their hydrocarbon chain.